I make $7.50 babysitting. So if I work X hours and Y is the amount I make for working X hours, that equation would be Y equals 750 or 7.5X. Is that direct variation? Well, let's take a look at what direct variation is, and then we'll come back to this question. A direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. A constant ratio is represented by K, or a constant fraction, between all your X's and Y's, meaning the constant or consistent Y out of X is that consistent value. So if we go back to the babysitting question, consistently, I will make $7.50 for every hour that I work. So Y is equal to 750X. If I isolate that 7.5, I will get Y over X is 7.5. That is a constant ratio between my amount of money that I make and the hours that I work, okay? That 750 is consistent. An example of something that wouldn't have a constant ratio is, let's say I make 750X plus I also just earn a flat $10 per week. So let's say I earn a flat $10 per week plus $7.50 for every hour that I work. Now, I don't have a consistent ratio between Y and X. My slope is 750, but I start at 10. My slope is 750, but I start at 10. Here, I start at 0 because it's Y equals 750X plus 0. So I start at home base at 0, and then the increase in Y is 750 for every hour. The increase in Y is 750, or the increase in the amount that I earn is 750 for every hour. Hence, this consistent ratio. Easy to check by saying, is Y over X equal to a consistent number? Yes, it is. So just to refresh your memory, a ratio is a fraction. So that means that that constant is the constant number that represents the fraction Y over X. So direct variation equations are written in the form of Y equals Kx, which is basically Y equals mx plus 0, because in order for K to be the same as Y over X, my Y-intercept has to be 0. So to refresh, K is equal to Y over X, and all direct variation equations have a Y-intercept of 0 and go through 0, 0. All direct variation equations, as a result of being just Y equals Kx or just Y equals mx, all direct variation equations have a Y-intercept of 0 or go through 0, 0. Think about the babysitting. You don't get paid a flat fee, you just get paid $7.50 per hour. That's it. So if you work 0 hours, you make $0. That is a directly variated relationship. So given ordered pairs, we're going to go ahead and identify the constant, and then we're going to write the equation to represent the relationship. So let's take a look at number 1. We have a set of ordered pairs, and we want to identify the K, the constant of variation. So remember that direct variation is the equation Y equals is a relationship between Y's and X's where they follow the equation Y equals Kx, where K, the slope or the constant of variation, is Y over X. So if we want to find K, these are Y's and these are X's, let's put Y over X to make sure that the K is consistent across the board. All right. So we put all our Y's over X's and we see that that's equal to 4, that's equal to 4, that's equal to 4, that's equal to 4. Since this K, or the ratio of Y over X, was consistent across the board, these ordered pairs represent a direct variation. And so the equation between those must be Y is equal to, not K, Y is equal to 4X. And K is 4. Can we find the slope in a regular fashion? Of course you can. So y minus y, let's take these two ordered pairs, y minus y over x minus x. That gives us 4 over 1, and that is our slope, or our k. So whether you want to find the slope, or whether you want to find the constant of variation, which is the slope, using y minus y over x minus x, you could do that. Or if you can recognize that this is direct variation, you could just put your y over your x. The way I recognized that it was direct variation was that I put my y over my x, and it was the same number always, all the time. This is a direct variation set of ordered pairs, and it's given away by the fact that it goes through the point 0, 0. Since it goes through the point 0, 0, that means that the y-intercept is 0, so it follows a y equals mx plus 0 or a y equals kx relationship. That is a directly variated relationship. So let's find k. K is the same as y over x, or k is also slope. So you can choose to do the slope formula, or you can just put y over x, 2 over negative 4. I just want to check that they're all the same, just to confirm. So that gives me negative 1/2, negative 1/2, negative 1/2. K has got to be negative 1/2. My slope has got to be negative 1/2. And this equation is y equals negative 1/2 x. And if you notice, y is negative 1/2 times x. Y is negative 1/2 times x. 0 is negative 1/2 times 0. Negative 1 is negative 1/2 times 2. Now you will try 3 and 4 on your own and answer the questions. For the next set, you want to identify the equations below that represent a direct variation. Well, remember that a directly variated equation is in the form of y equals kx. That is not an x. Of y equals kx, or y equals mx plus 0, plus 0. So let's take a look at the highlighted questions. In number 5, it is in the form of y equals kx, and my k is 3, so yes, this is directly variated. Number 7, y equals kx. I don't see an x there, so this is not directly variated. That's a horizontal line. That's a horizontal line through 2. 1, 2. And all directly variated relationships go through 0, 0 to the form y equals mx plus 0. Let's look at 9. All direct variated equations are y equals kx. That is not a y equals kx, so no, not DB. And number 11, we have one step to get y by itself. So we get y equals 1/2 x. That is definitely in the form y equals kx, where k is equal to 1/2. So this, yes, is directly variated. For number 13, let me isolate y. Y is equal to, subtract 5x, subtract 5x. Y is equal to negative 5x. And the answer is yes. There's my k. That is in the form of y equals kx. K is negative 5. Yes, it is directly variated. Now you will try 6, 8, 10, and 12 and answer the questions along the way. To identify the graphs that represent a direct variation, you want to remember that a direct variation is in the form of y equals kx, which is the same as y equals mx plus 0. So you're looking for lines that go through 0, 0. Direct variation equations are linear, and they go through 0, 0. So if you're looking at 14, 15, 16, and 17, you want to look at 0, 0, and you will see that you have three lines that follow a direct variation equation. That is 14, 16, and 17. And let's identify the k. Remember that the constant of variation is the slope. So let's rise and run. That rise is 3, that run is 2, so my k is 3/2. So the equation is y equals 3/2 x. Okay, let's take a look at 16. My rise is 2, my run is 8. Yep, 8, all right. It is negative, so my k is a negative slope, is -1/4. So y is equal to -1/4 x. This is not directly variated because it does not go through 0, 0. So it's going to be y equals mx plus b. And you can find the equation of that line, but the question was, does it represent a direct variation? Number 17 is directly variated. So my rise is 3, my run is 3. So my k is 1, and my equation is y equals 1x, or y equals x. Lastly, you are going to find missing values if you are given that the following ordered pairs represent a direct variation. So we know that the following ordered pairs represent a direct variation. That means that these ordered pairs follow a y equals kx relationship, and k is the same as y over x, or the slope is the same as y over x, okay? So we have to find the missing value. Well, first, you want to find k. Remember that k is equal, because they said it is a direct variation, so we don't have to check if it is. They are a direct variation. It was given. First, find k, which is the same as y over x. And in this one, we can find k to be 16/4. So k is 4, which means that this relationship follows a y equals 4x equation. And if y is equal to 4x, 16 is equal to 4 times 4, 24 is equal to 6 times 4. 24 is equal to 6 times 4, so x has got to be 6. Since the constant of variation is 4, that means that y is equal to 4 times x. 16 is equal to 4 times 4. 24 is equal to 6 times 4. Let's try another one. Again, it was given that these ordered pairs follow a direct variation. So we got to look for this missing value. So let's build the equation first. Let's find k. The k between them is y over x, also known as 24/6. So k has got to be 4 again. That means the equation, the direct variation equation here, since k is 4, that equation's got to be y equals 4x. And I'm looking for this missing x when y is -16. So what is x when y is -16? X has got to be divided by 4, divided by 4, -4. All right, now we just have words. If y equals 8 when x equals 32, so 32, 80. Sorry, I said 8, I meant 80. Find x when y is 100. Okay, so here we have x is 32, y is 80. Find x when y is 100. We were given that these were directly variated, so they follow the y equals kx relationship. K is y over x. So let's put y over x to find k. All right. We can reduce by 16 to get that k is equal to 5/2. So that means that these two ordered, or all the ordered pairs in this relationship follow a y equals 5/2 x equation. And when y is 100, what is x? So when y is 100, in that relationship, what is x? So multiply both sides by 2/5. That's equal to 1x. If we multiply by 2/5, those will cancel, but I got to multiply that by 2/5 to get 200/5 is equal to x. x is equal to 20, 20. Nope, not 20, 40. X is equal to 40. So to recap, I wrote these in ordered pairs, x comma y, so it would model the same as the one on top. Since it was given that these are directly variated, that means that these follow this relationship, y equals kx, y equals mx. So m, or k, is the same as y divided by x, or y over x. I took one that was filled out, I put y over x, and that gave me the common ratio, or the constant ratio, k, to be 5/2, which means my equation is y equals 5/2 x. This equation will help me find this missing value. Since this is an ordered pair, this y value and this x value must both fit into this equation at the same time. 100 is equal to 5/2 times x. Now I can solve this equation for x to get that it is 40. Let's do one more. If y is equal to -7 when x is -28, find y when x is 20. So we already know it follows a y equals kx pattern. So let's find k. K is y over x, or 1 over 4. So that means the relationship here is y equals 1/4 x. When x is 20, what is y? So when x is 20, what is y? Y must be 5. Now you will try your best at 18 through 24. Follow the promptings along the way, and that is the end of direct variation.